Namaskar everyone, my name is Aditya Ajmera, and in this lecture we are going to discuss a very important topic from the geomorphology, and this is the topic called the interior of the earth. So we are going to discuss how the earth was formed and how the different layers formed inside the earth and what are the material composition of the earth in these layers, and also we are going to discuss the transfer of energy, the mechanism of energy, how the energy transfer from the core of the earth to the crust, that means the surface of the earth. So suppose this is the earth, and it is around 4.5 billion years ago the earth was formed. It was formed at this time, and the earth was not like what we see today on the surface, like we have mountains, the solid surface. So at this time earth was in the molten state, the semi-solid state, and after 4.5 billion years, that means the present state of the earth, we have different structures inside the earth. So what happened at this time? There was a process of cooling. The cooling process radiate heat outward of the surface, and this result in the solidification of the surface of the earth. And the second process was the density adjustment. Density adjustments, that means the lighter material inside the earth will come toward the crust, the surface of the earth, and the heavier material will sink down toward the center of the earth. So this was the process happened during the initial phase, and up to this time this process is going on, and this result in the formation of different layers inside the earth. So we are going to discuss the different layers inside the earth. So suppose if we cut down a slice of the earth, what will happen? This is the outermost layer of the earth, and if we cut down, if we replicate a slice of the earth, it will look like this. The outermost layer of the earth is called as crust, and the lower level just below the crust is the mantle, and then comes the core. But we have different models which describe the interior of the earth, and in this lecture we are going to discuss the model called as model based on the state of matter. So according to this model, we have different layers which formed on the basis of the state of matter. So we have discussed the crust, and it is up to the depth of 40 kilometers. This model talk about a different layer which is called as lithosphere. This lithosphere is the outermost layer of the earth, and it is up to the depth of 100 kilometers. The lithosphere is up to the depth of 100 kilometers. Then we have the mantle, but this model says the mantle is also separated into two parts. The first part is called as upper mantle, also called as asthenosphere. And it is up to the depth of 700 kilometers. And the second part is called as the lower mantle, and we can find the depth of lower mantle up to the 2900 kilometers. Then comes the core. So this model says the core is not a single unit, it have two different parts. The first part is the outer core, and the second part is the innermost, the center of the earth. We have the inner core. The boundary between the outer core and the inner core is up to the 5200 kilometers. So this is how the different layers formed inside the earth in between these 4.5 billion years, and this is the result of density adjustments. So that means we have different kind of materials and the different state of matter we can see inside the earth. So if we talk about the first state, the first layer, the innermost layer, this is the inner core and it is in the solid state. Solid state. The outer core and the inner core both constitute the same material. Both have the predominant presence of ferrous and nickel. So why ferrous and nickel we can see inside the core of the earth? Why? Because ferrous and nickel have the most stable nuclei among all the elements we can see in the periodic table. So under the high pressure, the whole weight is exerted on these layers. So what happened? All the elements will transform into new elements, will break down and transform into new elements. And this is how the ferrous, which have the most stable nuclei. It is a topic of science and tech rather than the geography, but we can understand why we find ferrous and nickel inside the core of the earth. Also, the core of stars have the dominance of the iron. Iron is the major constituent element inside the core of stars also. So what is the reason behind this? The stable nuclei of the ferrous. So this is why we have the ferrous inside the outer core and the inner core. But the outer core is in the molten state. Molten or semi-solid state. Why the solid state we can find in the inner core and the molten or semi-solid state in the outer core? Because the weight, the pressure exerted on the inner core transform the material from molten to the solid state. And why we have molten state in the outer core? Because of the high temperature. The region in the outer core and the inner core have around 6,000 degrees Celsius of temperature. 6,000 degrees Celsius. This temperature is enough to melt tungsten. But why we have inner core in the solid state? Because of the high pressure exerted by the other layers on the inner core. Then comes the lower mantle. Lower mantle we find in the solid state. Solid state. And the major elements we can find inside the lower mantle is silica and magnesium. We have the layer, we can see the CIMA layer inside the lower mantle. The upper mantle, also called as the asthenosphere, this layer is in the semi-solid state. Why semi-solid state? Because it have high temperature. This is the layer when the density adjustment process was happening in between these 4.5 billion years. Many radioactive elements like uranium, thorium, plutonium, these kind of elements get consolidated inside the upper mantle part, also called as the asthenosphere. These elements radiate energy. These are radioactive elements and they radiate energy. And this energy raises the temperature of the material inside the upper mantle, also called as asthenosphere. And this is why the asthenosphere is in the molten state. And the uppermost layer of the earth, called as crust, up to 40 kilometers, or lithosphere up to 100 kilometers. The crust is mainly in the solid state. Solid state. So this is our planet Earth, and it have the energy inside the core of the Earth, which travel through these layers and reach up to the crust. And this energy, when hit to the crust, various kind of events we can see, like the earthquake, volcanic events. These events are the result of this endothermic energy which come from the crust, the core of the Earth, and reach up to the crust. So now we are going to discuss the mechanism of energy transfer inside different layers of the Earth. This is the inner core and it is in the solid state. So we have nickel and ferrous. These elements are solidified under the high pressure inside the core. and that means these are metals and they will transfer the energy in the form of conduction. Conduction process we will see inside the inner core, and just above the inner core we have the outer core, and it is in which state? It is in the state of semi-solid. So semi-solid state material have the mode of energy transfer in the form of convectional currents. Convectional currents. So what are convectional currents? We have discussed the density adjustments, like this is the material with high density. When it will reach at the boundary of inner core, the temperature is very high. This will expand and the density will get decreased. Then what will happen? If the density get decreased, this will try to rise up toward the lower mantle. When it will reach up to lower mantle, what will happen? Lower mantle have lower temperature compared to the outer core. The energy will get out radiate and this will get cooled and shrink. When the material will shrink, what will happen? The density will get increased. When the density will get increased, what will happen? It start to sink down toward the inner core, and this will make a circular motion, and this circular motion is called as convectional currents. Same convectional current we will see in the asthenosphere, and also we are seeing in the outer core. The convectional current is the mode of the mechanism of energy transfer in the outer core. So this is how the conduction process and the convectional process we can see in the core region. Then comes the lower mantle. This lower mantle is in the solid form, and if the matter is in the solid form, then what will be the mechanism of heat transfer? The mechanism will be conduction. But we can see here we have the silica in huge amount inside the lower mantle. Then what will happen? This silica will act as a insulator. Silica is not a good conductor of heat. Silica is a bad conductor, or we can say the insulator of heat. So the conduction process inside the lower mantle will be very low, very slow conduction process. Very slow conduction process we can see in the lower mantle. Then the energy will reach up to the boundary of upper mantle. What will happen here? Upper mantle, also called as asthenosphere, we have discussed. This is in the semi-solid state like we saw in the outer core region. The semi-solid state have the same convectional currents, like the lower density material will rise up, it will reach up to the crust, then it will radiate its heat and density will get increased and it will start to sink down, and this circular motion will transform the material into a convectional current, and this is how the energy get transferred in the asthenosphere in the form of convectional currents. This endothermic energy will then hit the crust in the form of earthquake, in the form of plate tectonics, and in the form of volcanic events, and this is how the energy transfer from inside the interior of the earth toward the crust, and this is the mechanism of heat transfer between the different layers of the earth. So we have discussed the different layers. We have different boundaries between these different layers, like the inner core and the outer core have the boundary called Lehman discontinuity. There comes the Gutenberg discontinuity between the lower mantle and outer core. Then comes the Rapethy discontinuity between the upper mantle and the lower mantle. Then comes the Moho discontinuity between the crust and the material just below the crust, which is in the semi-solid state. So we have discussed how the earth was formed and how the density adjustment process transformed the interior of the earth into different layers. and how the energy travel from the inside, from the inner core toward the crust. So we have discussed this topic. Thank you.